Thank you, Brennan, so much for the insights already.
No problem.
So welcome everybody to today's session of Pi and AI. We have a special guest today from a university. He's going to help us today to understand the myth around AI. And I'm expecting, so I've already learned so much already, just a few minutes into the call. But before we start, as tradition demands, I'm going to play a very short video, 4 or 5 minutes, from our lead presenter, that's Andrew Ng. And I hope you enjoyed that. So just a quick short session and we'll come to it as we take off. So I'm going to share my screen. It's a minute.
Hello, deep learners. I'm Andrew Ng, founder of deeplearning.ai, and I'm excited to welcome you to our global deep learning community. I know that many of you are here today because you want to break into AI and build your career. I hope that being part of this community will help you to do so. To give you a proper welcome, I'd like to show you around the deeplearning.ai offices and meet some of the teams so that you can see where it all happens.
Oh, hi, Andrew.
Do you want to tell our friends at Pi and AI what you do at deeplearning.ai?
Sure. Hi, everyone. I make articles and other media that help people learn about AI and help them understand the huge impact that AI is having in the world. Today, I'm putting together the next issue of The Batch, our weekly newsletter, and I'm looking for the biggest stories of the week to keep our readers informed.
What's been the most surprising thing you've run into working on The Batch?
How much is going on in this field? There's never a dull moment. You might think from the outside that machine learning engineers really understand everything about AI, but nobody understands everything about AI because this field is just coming to life right before my eyes as I put this thing together every week.
All right, I know you're really busy, so I'll let you get back to it.
Thanks. See you later.
Let's go meet Kian, who helped me create the deep learning specialization. He's working on an exciting new project. Hey Kian, so do you want to tell the people at Pi and AI what you're working on?
Yes, sure. I'm leading a project called Workera, focusing on helping people get offers in AI and navigating their career by testing their skills, preparing for interviews and certifying them, as well as matching and referring them to good jobs in AI.
That's really cool. And what's the most exciting part of your day?
You know, the AI field is new, organizations and jobs are still misunderstood. So I'm excited to help people understand what different types of jobs exist in the field, what tasks they will work on, and what skills are needed to achieve those tasks.
Yep, that's really important work. Well, it's nice chatting, and now let's go chat to Hotel, who is on their product team.
Hey, Andrew.
Do you want to say hi to our friends at Pi and AI and let them know what you're working on?
I would love to. Hi, everyone. I lead the product team in deeplearning.ai, where we create AI education content accessible to people all around the world. People like you.
And what are you most excited about right now?
I am so excited to see our community grow and to see how eager people are to learn more about AI.
Thanks, Osel.
Thanks, Andrew.
So, as you can see, our team is working hard to support you and help you learn. It's never been easier than before to break into AI. So if you want to build a career, you can leverage online resources available, including open source code, datasets, papers, and online courses like a deep learning specialization on Coursera. As part of this journey, I hope you get your hands dirty too. Don't be afraid of diving in to build your own project. Or go ahead and try to replicate a research paper that you're excited about. One thing that I've seen help a lot of people succeed is if you can build a community or find a community of fellow deep learners you can meet with and study with on a regular basis. In fact, I hope that this Pi and AI meetup that you're at right now will be a good place for you to meet these people. I hope you enjoyed the event today and that you learn a lot, both from the talks and from each other. And once again, welcome to the deeplearning.ai community.
All right, everybody. Thank you for hanging on in there. Welcome back once again. My name is Godwin. I'm joining the call from Accra, Ghana, and I'm the ambassador for Pi and AI or Deep Learning AI in Ghana. And this is our community meetup where we get to invite different guests. Sometimes I host my own sessions. I invite guests as well. Last week we had how to monetize AI, and this week we are looking at what's really real. Okay, AI myth and reality, the 5 capabilities of AI. So today we have a special guest, Professor Brandon Purcell. He's the director of the Center for Data Analytics and Applied AI, DeSales University. I really never knew the university, but first time getting to know it, and maybe he'll tell us a little about what he does. And so today's session is going to be more presentational. So the doctor is going to present, I don't know, he's going to talk about how his talk. Then at the end of it, we are going to ask him questions and answer. Already, I've got some insight already into a model I'm looking at, and I believe it's going to be an insightful session. So, Doctor, over to you, please.
Thank you, Godwin. Thank you much. Let me share my screen. This here, share. All right, and then let me bring up this. I need to get this into presentation mode. All right. Then let me put this over here. Okay. All right, so this is introductory, correct, Godwin? And so I'm going to approach this for people who don't know much about AI, haven't been spending much time with AI. And yes, so the topic is AI myths, AI rules, and then AI capabilities. I published a book a few years ago called Outsmarting AI about this, and my goodness, things have changed since that book came out. However, I still see key elements of AI algorithm architecture, of application architecture that have not changed. So I think still most of the arguments in that book hold true, even if there are significant changes. This, as was said in the introductory video from Andrew Ng and his team, this is an incredibly lively space with innovations happening left and right, the world over, and the speed at which people share these technologies and the speed at which they are being adopted and used is just, it's alarming. So we are in turbulent, exciting times. Okay, so this first slide is just in general, and I want to move this thing. Wait, let's put this up at the top, talk to the top. Okay. Oops, sorry, I'm just adjusting things on my screen so I can see a little better. Okay, right, so artificial intelligence. I really think it is absolutely true that artificial intelligence is just, it's just a name. It's not artificial, it's real. It's just computer software working on computer hardware, like any other application. Intelligence. Well, let me say, I really don't think it has anything to do with human biology, neuroscience, maybe by analogy. It just does not work like human cognition. And of course, all the different forms of human intelligence. There's people with just good old IQ. There's people with calculation intelligence. There's people with emotional intelligence. There's people who have terrific logic. There's people with very physical and spatial intelligence. You can see this in terrific sports stars. Intelligence is a concept. It is uniquely human. I think it's best to understand AI. I'm not quibbling with the term. It's just part of data analytics. Without data, AI is useless. But I'll come to that later. So this slide just says what AI has been called. It's been called the new electricity, in the sense that this, when electricity was kind of captured and transferred and controlled and turned into a product, at first it made some kind of remarkable small changes, but there's more and more uses over time for electricity, for over a century now, well over a century. And there's just more and more uses for it all the time. So the idea behind AI is that this is not a sudden discovery that will change things. There will be more and more uses, more and more capabilities. It's a new development. Some people have tied it to something called the fourth industrial revolution. I don't want to get into the history of the Industrial Revolution with the advent of burning coal and smelting iron and early contraptions in the 1700s and 1800s in Britain and Northern Europe and the United States. Don't want to go there. But this has been called another industrial revolution in the sense that it can really boost automation of especially what we call in the United States white collar tasks as opposed to blue collar tasks. I'm not sure if you have these terms, but it's in the 20th century, robotics automation brought huge leaps in productivity in manufacturing, in more physical tasks on conveyor belts and assembly lines. What we're seeing with AI, and particularly with RPA, with robotic processing automation, is computers are getting better and better at automating kind of repetitive tasks that you can do with them, working with any kind of data, opening up applications, well, putting in credentials, logging in, downloading data from here, transforming it in this way, deciding, making these decisions, and then generating other outputs. We are seeing, and I really believe there will be enormous productivity leaps, especially in text-based, what used to be paper-based, now digital-based products and processes associated more with office work. And then the second machine age, the early machine age had more to do with heavy industrial things, and then we have more finer and finer robots. And now we're getting RPA, we're getting the digital bots that are taking over more and more services. Okay, we'll move on to the next one. Okay, so I'm just repeating this line from the other slide. Artificial intelligence, it's really a form of data analytics. And when I refer to data, I'm just talking about digitized records, readings from sensors, other equipment, and just evidence. Some people like to say data is facts. I think a fact will only be a fact if the data were accurate, if the measurement were true. Some data produced is garbage. Not all data is high quality. Some people refer to data as information. Well, again, I think information is an appropriate term if it's accurate, if it's true. Otherwise, it's misinformation or disinformation. And anyone who has spent time on the internet knows, and in social media, anyone knows that we have a problem with misinformation and disinformation and people just putting up garbage and falsehoods. We really struggle with that in the United States, but I suspect the world over, it's a problem because people have the unique ability to lie and to deceive, and that's just a human problem. So data is just digitized records, readings, and evidence. Analytics, just math. You know, when it comes down to it, AI is just math. And then, of course, we have statistics, the field of statistics. These are mathematical formula, put math and the statistics together. It's just algorithms, mathematical procedures applied to digitized data. And then we have three kind of great branches of data analytics. There's descriptive, which really tells you, it answers questions about what happened in a certain situation, in a certain problem. It's more focused on the immediate past. It's descriptive, it describes. We have predictive analytics, in which we take data and then we ask the algorithm to make a prediction. Given what happened in the past, given this data, what is going to be the outcome of this procedure? What is going to be the cost of this item? When will this item arrive in supply chain analytics? We ask it to answer a question about a future prediction. I didn't put classification in there, but we'll come to that again when we get to AI capabilities. And then finally, we have prescriptive analytics. Sorry, prescriptive analytics. Prescriptive answers the question that everybody wants to know in every aspect of business. What should I do next? What should we do next? If you're in sales, what should be the next customer that I visit? I have 200 possible leads, prospects for customers. Which is the one most likely to say yes and to accept our services, where we can make the sale, as it said? In medical, what is the next procedure? What's the next drug that this a patient should receive. That's what prescriptive is. There's an element of predictive analytics. There's an element of descriptive analytics, predictive analytics in prescriptive, but prescriptive takes another step. So I think it's very important to bear these simple ideas in mind when we look at the analytics and then firmly root artificial intelligence in data analytics. Without data, AI is garbage. Okay, what we're seeing is an increasingly rapidly developing digital transformation. I'm old enough where when I was at school, I did everything paper. And then over time, what we see is the advent of the personal computer and more of the things, more of the calculations and the problem sets and the papers, the different writings we did earlier was all on physical paper, right? Physical paper. And now now everything's digitized. And then, of course, photography earlier was done on special photographic paper, all digitized. Audio was done on magnetic tapes, all digitized. Video, everything digitized. So what we're seeing, especially with AI, and we will get to this, is its ability to generate any kind of digitized content. This is part of the digital transformation. The three main components of this is cloud computing. All right, the laptop and the desktop computer, these are terrific tools, but given the quantities of data that you need and the complexity of the algorithms and just the intensity of the training, the amount of computer resources you need to train or fine-tune an AI solution, it's kind of best done in the cloud. And so we've seen an enormous growth of the great worldwide leaders of cloud computing, Google Cloud, Microsoft Azure, AWS, Amazon Web Services. I'm sure there are many more. The building of data centers across the planet. Take cloud computing, which sets up these platforms where you can upload your data and have a place where you can drop the Jupyter notebook to put in the algorithms, to put in the code, to perform the algorithms, to get your results. It can all be done in one environment. So you don't have to deal with the limitations of the personal computer or the burdens of the OS, of the operating systems, the dependencies. Cloud computing really helps to cut through that. Data is just the fact, good heavens, there's more data than anybody knows what to do with. These phones, the smartphones are just about everywhere. Every piece of heavy equipment generates tons and tons of data. Every airplane engine produces petabytes of data per hour, or at least terabytes. There's tons of data. And then we have 5G. 5G, of course, we have LTE and 3G and 4G and 5G. The speed at which this data is transferred wirelessly is just only growing faster and faster. And of course, there's the IoT, the Internet of Things, which is the linkage, the explosion of more and more devices that are linked to the internet. They have just enough power to transfer their data to a local gateway and to within their sensor readings or whatever data they're generating can be uploaded to the cloud for analytics. These are the three main components of digital transformation that's going on. And so what I see is there's major change, major disruption in the way work is done in these fields, in finance and banking and insurance, the rate at which procedures that used to take time, more time done by a human on paper-based documents, it's all rapidly being digitized. It's almost becoming immediate in some cases. In sales and marketing and advertising, of course, that we're referring to the great Google revolution and my goodness, I mean, the advent of search and then using analytics on search to anticipate people's needs, hyper-personalization. This is where some of the richest companies in the world have been put together. Above all, Google and Facebook, now Meta. In logistics and transportation, I heard the other day, it's still the case in the United States that all the containers, those great big shipping containers, great big giant steel boxes that get stacked up on enormous ships and shipped throughout the world, and then put on the back of trucks and trains, that over half of them in the United States don't have a connection to the internet. They don't have a traceable RFID, a radio frequency identification. And these little devices are very cheap these days, and with a simple power source, everything could be trackable. In logistics and in transportation, we're rapidly getting to a situation where nothing should get lost, where if there's just a simple little device that can connect the container or the box being shipped to some form of internet gateway, nothing should get lost, because there are losses in logistics. Healthcare. I don't know what it's like in your country. In the United States, we're in a terrible situation. The costs are going through the roof, and the public health needs are only growing. There's immense pressure on insurance companies and on federal and state programs to cut costs and enhance services, and this will add more pressure on. This will add more of an opportunity for AI healthcare applications. Whether that's a good thing or bad thing, that's another issue. Just to go quicker, in retail, there's major disruption underway. Social services and government, good heavens, I wish there were more disruptions underway. Government, at least in our country, seems to be the slowest with technological adoption. I see Godwin grinning. I see your beautiful smile there, right? You know this too. Government is most likely to say, no, we do it the way we do it, and we're going to take time. I was just reading this morning how the county of Los Angeles, which has about 2 people in it, sorry, did I say 2 people? 2 million people in it, one of the largest counties in the United States. Finally, its court system digitized its records. So what we're getting now is someone who was released from a prison sentence and on probation, who had a mental health breakdown and broke probation, was called in to court, and his lawyer was called in at the same time. You may say, what's remarkable about that? He had been checked by a medical professional, and they said this guy is having a psychotic break. He can't tell what's going on. Yes, he broke probation, but good heavens, he wasn't doing it in order to commit a crime. It's because he's kind of lost his mind. But the fact that he appeared at court at the same time as his defender meant that he didn't have to be locked up in jail for 2 weeks, which meant that he would have lost his job and got thrown out of his apartment. And if there were any dependents depending on him, I mean, I'm sorry, I don't know the details. If he had lost his mind, how could he have done this job? But the point is, we have these very slow government systems where, okay, just grab a suspect and just put them in jail for weeks before they may get arraigned and may be told what they're charged for relatively quickly, but then they just sit there, and if the wrong person were caught, they do lose their jobs, they do lose their apartments, their families do fall into poverty. We need to have a faster system. Why does everything have to be done on paper? Why can't they have digital documents and just keep track of these things? There's a line from Shakespeare about the law's delay, and it's very real. I dream in the United States of a bot for filing your taxes. The piles and piles of forms, these paper forms, this is 19th century technology. I don't know about the tax code in your country. The tax code in our country has millions of pages, and even to do a simple filing is an arduous affair. Why can't we have a bot that does this? You just scan in your documents, your earnings reports, and just let the bot take care of it. There should be a way for you to challenge the decision, to escalate the calculation of your taxes, to say, I don't think that's accurate. But for people who say, no, that's about right, we're good, there should be that. I hear they're working on it. Legal services. Godwin and I were just talking about this. Boy, is there any field more totally reliant on long legal text documents that could really benefit from the efficiencies and the productivity of using LLMs, large language models, such as GPT-4, ChatGPT, Bard, Bing, Llama, Claude. There's many of these models. And then in education, I'm in education, and I think all of education, we're shaking in our shoes. We have never, I don't believe, in the history of all human education, we have ever had a tool, a technological tool with no brain that can produce, that can solve the problem sets, the word problems. Yes, we've had calculators that do the calculations, but that can solve the problems, that can write the papers, that can do the problem sets in chemistry, that can produce the spreadsheets, where you can upload whole books and it can summarize it for you. We have never had a tool that can produce such human-like output. And it's raising all kinds of questions. Yes, we are in turbulent times, and I don't know what's going to happen. AI reality, the reality of AI, it's just math. That's what computers do. They just do math. Ones and zeros doing mathematical calculations. It's just software working on hardware. AI, as I said before, has nearly nothing to do with human cognition or neurobiology, maybe by analogy. But the math is absolutely terrific. And the computer code, and above all, the software, the free open source software libraries, and then these cloud computing platforms make it easy. And the fact that text can be turned into tokens, words can be turned into tokens, and then these algorithms run, you can have this machine producing intelligible text reliably in most cases, but not in all. That's just the reality. So there are 7 AI myths, and these are the same myths that I published in 2020, and I believe they still hold. I'm the first to admit there's much in my book that has become obsolete. Whole portions of the book are obsolete, but I believe these myths still hold. Many people think that AI is a robot. It's not. A robot is a device that does things. AI, there's many bots, software bots that are AI, but AI is not a robot. Okay, Saudi Arabia took this robot named, the Kingdom of Saudi Arabia took this robot named Sophia and gave her citizenship. I think that was a PR, a public relations move to make them look forward-thinking and technologically savvy and cutting edge. But no, AI is not a robot. AI knows what it's doing. It doesn't. If it knew what it was doing, it could second guess itself. It could exercise skepticism. It could catch its errors. But if you want to see the errors, just log into some large language model like GPT-4 or something, and get it talking. Have it just say, write up a Wikipedia biography for me. And it'll start and it'll get some things right for you, do it for you, and then it'll just start making things up. The longer you have it right, the longer you prompt it to produce more text, the worse it gets all the time. It doesn't know what it's doing fundamentally, even if it can do some remarkable things. AI is inescapable. Well, it depends on your field. I really don't think AI will help with plumbing and building houses and doing haircuts and baking fine goods. However, there are some fields where it's becoming more inescapable. AI has insight. It drives me nuts. All the time we hear about people selling services saying, oh, AI can find insights in your data that you would never see. Well, there are many machine learning algorithms that can identify patterns in your data that you didn't think of, but it takes a human to see whether those patterns, those associations, those correlations have any realistic business-related insights. The human has insights, not AI. AI means easy money. No, it really doesn't. AI projects in the United States, this has been studied. It's still floating around a 60% failure rate. And what I really deeply appreciate about deeplearning.ai, and all of the courses, there are multi-course learning paths you can take, TensorFlow and deep learning, but there's also more and more short little 1-hour courses about diffusion models, about fine-tuning large language models. The people in Andrew Ng's team are very honest. They're very truthful. They're not out to steal your money. And they will be very upfront about the high failure rate. They will say that sometimes you get all your data and you've done everything and you've cleaned that data, you've prepared that data, and you think this is really going to work. Sometimes it just doesn't work. Sometimes the model just doesn't work, and ultimately you don't. Millions, hundreds of millions of dollars have been squandered in the United States on pointless AI projects that fail. It does not mean easy money. So people have to be careful. And the number one biggest problem is number 6, AI drives businesses. The idea that you can turn over an aspect of your organization, like hiring or firing or quality controls or fraud detection. The idea that you can turn these procedures fully over to AI and fire all the people and save the money, that is false. AI can be incredibly fast, it can be remarkably accurate, but it needs to be governed. It needs to be tested. When data changes, when things change, it doesn't know what to do. My favorite example of this is, it's called Danske Bank in Denmark. They were lionized. They were celebrated as being a forward-thinking, technologically advanced bank, and they had all of these AI tools to catch fraud. And there was great publicity about it. And then it came out that that bloody bank had laundered about $200 billion. $200 billion in money stolen from Russia by Russian oligarchs. They were stealing money and pocketing their own accounts, and they would run it through Danske Bank. So clearly there were some people in there who knew exactly what to do to get around all the AI controls. I mean, it was, when that came out, I laughed my head off. It's human hubris. Yes, use AI tools. Yes, experiment. Look for ways to make your business procedures more productive, more efficient, more accurate. But my God, you have to test. You can't just say, okay, great. And then I have other examples of this, but we don't have time. And then down here, number 7, AI will control your mind. Well, there are some people, have you heard of, well, everyone's heard of Elon Musk, one of the richest people on the planet. He has many, many companies. He has a startup called Neuralink. And apparently he has a number of his Muscovites, a number of his followers who volunteered to have little tiny holes drilled in their skulls for microfilaments or little electronic nodes fed into their brains. And he said that the idea, the vision of the company is to eliminate all schools, because you could just get these wires drilled into the back of your brain. You can upload information into your brain, because the brain works like a big computer chip. Godwin, you're nodding. Have you heard of this story? I'm just wondering. I think it's just totally hilarious. Trying to get one machine that works one way to interface with this biological phenomenon, the human brain. I mean, this to me is the height of folly. That being said, in neuroscience is just discovering more and more things about the brain, but I'm sorry, the computer just doesn't work like the brain. The idea that you can just upload information is kind of crazy. So the people, we have a sad tendency in the United States where the richest people in AI, like Elon Musk and Sam Altman and Sundar Pichai, are putting out these warnings that AI will soon control everything, including your mind. And we have to guard against it. Yes, we have to have regulation of AI. Of course, they want AI regulation that protects their market position. But they're the ones trying to scare people the most. The richest of the rich are trying to scare people the most. And I think they're just trying to jack up the price of their shares. AI is not going to control your mind unless you let it, unless you let it take over your schedule, unless you give it your credit card. People are working on the AI agent that you just tell it what to do and it goes on the internet and does it. You want AI to control your affairs? There are an increasing number of ways in which you can let AI make your decisions for you. People who are addicted to social media, to TikTok, to Instagram, the people who start many of my students are like this. They start scrolling through the social media feed, which has AI paying attention to what you look at and what you like and how long you look at it. If you come back to it, and it will send you more of this content. So they say themselves, my young people, my students say, we go down rabbit holes and we just get addicted to it. They are letting an AI algorithm control what they see and filling their mind with images and content. So yeah, AI will control your mind if you let it, but I can't recommend it. AI rules. I believe these are still very much enforced. Think of data. I hope people don't mind if I use the family metaphor. Think of data as the mother of AI. No data, forget it. AI just doesn't work on its own. Math is the father of AI. It's just math working on digitized data. Like kids, AI systems are unique. Every model you train up on your data is going to be a little different from other models. Okay, some of the great cloud-based models aren't trained on data, but especially AI systems that you build for your entities, and train on your data, they will be unique. AI needs parenting, it needs governance. Children need to be looked after. You'd never give small children control of your house. You'd be a fool if you did. And things wouldn't go so well. It'd be chaos. Embrace the cyborg. What that just means is the more open we are to AI, I think it's incorrect to say ban all these things. I have colleagues of mine that say no student is allowed to use ChatGPT in my class. Well, here's the problem. If you ban it, you can't enforce it because none of the detectors, the AI detectors, really work. So embrace the cyborg. Try these tools. See if they boost your productivity. See if they help your business. But be very skeptical because they don't know what they're doing. Platform is key. Cloud computing platform. Okay, maybe you don't trust the cloud. Maybe you have many computer servers and you can manage it all on-premise in your own hardware. Fine. Regardless of where the platform is, whether it's in the cloud or on-premise or some kind of hybrid, the platform needs to function because computers can store an immense amount of information and they can do an immense amount of calculations. The latency, the slowdown is in transferring the data, and having a unified platform is really very important. And then finally, abide by the law and act ethically. We're in the United States, I'd say we're almost in the illegal Wild West. There's some municipalities, some cities that have some regulations. We have some states that are doing some things. The federal government says it's going to do things. I'm just not sure if it will or in an effective way. We'll see. We have a hyper-partisan situation where both parties seem most committed to the idea of stopping what the other one is doing. Maybe you have better or worse situations in your own states. If the law is ambiguous, we should just act ethically and, as they say in deep learning.ai courses, just do no harm. Make sure that the data you're working on is never released so that people are harmed. Make sure that the outcomes and just control what it does, check what it does, test, so that people are not harmed. There's no point in doing this. We make the world even worse than it already is. So, AI's 5 capabilities. I still think this list is pretty good. Right, predictive analytics. So when it comes, if you remember, descriptive, predictive, and prescriptive analytics, AI, by now, I think it's fair to say AI encompasses all machine learning algorithms, simple regression, linear and logistic regression, k-nearest neighbor, Bayesian theorems. Okay, all that may be properly part of machine learning and statistics, but AI uses those to do predictions and also classifications. This takes us on to number 2. I have image recognition. I should say image video file, any kind of, I should say, multimodal recognition or classification. When I mean multimodal, I mean now AI is really good at taking any kind of file, whether it's structured data, like a table with columns and rows, or whether it's an image file or an audio file, or just about anything, and then, if properly trained, classifying what it is. That's something it can really do. Natural language processing, number 3. Taking language, just text files, working with them and summarizing the content, doing sentiment analysis. Is this more positive? Is this more negative? It's getting better and better doing this. Earlier, it was kind of weak, language translations, but my God, it's getting better and better all the time. But it's still based on statistics. And it doesn't always catch the subtleties of human language. And human language is immensely complicated. And this is an ongoing challenge. But it's getting better and better. Number 4, data transfer, RPA. Okay, some people say, I believe Andrew Ng himself said, no, RPA is not AI. Well, fine. I mean, he's a great leader of AI. I'm not challenging anything he says. And he's a wonderful human being and is really not out there to take money away from you. Andrew Ng and his organizations, it's just wonderful. But RPA, robotic processing automation, uses predictive analytics, image recognition, natural language processing, and data transfer, can open up applications and get reports out, do transformations of the data, some simple data processing, and then produce emails or take results of that, put into other things. That is part of this great wave of automation of professional work. That, to me, is kind of AI. It's AI doing tasks that people can do on computers. And then 5, what's really exploded in the last couple of years, of course, is content generation. 3 years ago, AI was perfectly capable of producing text, of producing images, producing audio, producing video. It just wasn't really very good. And we've, over the winter, from December 2022 through January, February 2023, ChatGPT went viral and people woke up. And then DALL-E 2 turned into Midjourney and some of these other tools where just based on a text prompt, you can get terrific images. Now from a simple picture, you can have it tell a story. It's multimodal. From a text prompt, you can produce a video. It's really quite amazing. I started with this, we are heading rapidly to a situation where if you can, anything you can do, any content you can produce, I'm sorry, it looks like I'm waving at you. I'm waving at my laptop. Anything you can do on a computer, pretty much, AI can do it too. Is it appropriate? Is it accurate? Is it correct? Is it ethical? You have to check that. But boy, it's getting good. So these are my 5 capabilities. Let's see. I'll wind up in 5 minutes. Let's see if I can do this in 5 minutes, and then leave time for questions for conversation. Why do I think a lot of my theories still hold? Because deep learning, we have machine learning algorithms. I went over some of them, and then we have deep learning. The neural network is still at the heart of the architecture of large language models, where you have a column of data inputs, and these are all numbers, and every single one of those numbers are fed into something called a hidden layer. Every single one of these numbers, and there can be millions of them or billions of them, they're assigned a weight, which is just a number, and that number is multiplied by the weight, and then there's an addend, another number is added to it, it's called a bias. And so in the hidden layer, every single number has its weight and a bias is added, and then you get a number. And then in another layer, each of the numbers that come out of layer 1 are recalculated in layer 2. And then there's a final output. There's transfer functions. There's more to this, but the point is it's just math. And then within the neuron or the node, that's what they call these little functions, where you have your inputs. It's just another graphic for it. And they're assigned a number called a weight. Here's your input, x1, and that has this other number, the weight, W1, Wi, and you sum them all up. You just add them all up, and then you add, and you can't see it here, but there's a little white B that's plus the bias, and then on it goes to the transfer function, and you get your different outputs. There's the log sigmoid function, which is so important in logistic regression, where any output, if it's a gigantic, if it's an extremely negative number, this little function presses it into a 0. If it's an extremely positive number, this function turns it into a 1. So there's different functions that can take these enormously divergent numbers and just press them into everything between a 0 and a 1. There's also the ReLU function. I'm not going to get into this. The point is, the neural network, your standard feed, forward, multi-layer perceptron, and then the output functions, they haven't changed much. They're still there. And then above all, and this is just a little graphic for this thing called backpropagation. Backpropagation is the process. It's the algorithm by which the weights get adjusted. So you have every numeric input gets assigned a weight and gets all multiplied and added up, and then it goes here. Backpropagation measures the difference between the output that you get and the output it should be. That's your Z. This happens in training. It measures the difference, and then it does backpropagation, taking that difference that we call the error, it adjusts the bias, it adjusts the weight, so that when you train it again, you see if it works better. It's called stochastic because it's just trial and error. It doesn't know what it's doing. These are the 6 equations for backpropagation, and I couldn't really take you through them. Andrew Ng himself in his training program says this is some of the most difficult calculus you will ever see in your life. You don't have to do this because in the deep learning frameworks, in the libraries, you need one line of code that does backpropagation for you. I'm going to skip away from this slide so that none of you have the feeling of, oh my God, I'm never going to learn this. I'm sorry, Godwin, were you saying something?
Mathematics.
What'd you say?
Math is we're getting into mathematics.
Yes, but the point is, it's just one line of code. That's really all it is. And then just very briefly, you can learn about all this through deep learning.ai. What you do is they measure the loss. It's called the loss. It's the difference between the output and the output from the neural node, from the neural network, and the outcome it should be. And then it graphs it on a graph, and you try to get this, it's called a gradient. You try to get it closer to 0. This is another appallingly complicated function that, again, you can just do with like one line of code. And they chart, this is this beautiful little 3D visualization of your gradient descent. You want to get the loss as close to 0 as possible. By getting the loss, the error down to 0, you're making your algorithm, your neural network, more accurate. This incredibly complicated math is just kind of built into the system. And then I'll wind up with this in the interest of time. People talk about AI being a black box, saying that you can't tell. Okay, once you've trained up your system and it's doing a good job and you've trained it up and it's giving you the outputs you want it to on the data you're putting in, and then you set it off, how can you tell how it makes its decisions? Well, here is CW1 up here. Here's a list of all the weights, the numbers that are just factors. They're multiplied. The inputs are multiplied by these things. And here's your biases. They're all zeros in the first hidden layer. And then here's more weights in the second layer. Here's more zeros. That's just the tiniest little neural network you could possibly imagine. Now imagine hundreds of thousands of these numbers, or millions, or billions, or even trillions. You can't tell. There's a real problem with the black box. It doesn't know what it's doing because it's just doing math. And then there are ways to use sensitivity analysis to figure out, well, how does this thing work? You change your inputs, you perturb them, and then you see the change in output. There's ways of working with these things. But anyway, I don't want to keep going down that track. what I'm trying to say is at the heart of all AI, as far as I can tell, pretty much, we still have neural networks trained by backpropagation, whose performance is improved through stochastic gradient descent. It's still a stochastic kind of trial and error process. Until that fundamentally changes, and people are suggesting new architectures now so that AI can understand more about reality and context, then I maintain that the myths still hold, the rules still hold, and these are still the AI capabilities. Okay, I've gone on long enough. I better stop sharing and turn it over to Godwin and everybody else. Questions? Anything anybody want to talk to? Please just unmute and turn on your video camera so I can see you, and fire away. Let's talk about whatever's on your mind.
Hi, Dr. Brannon. Thank you so much. Yes, we have a first question. Please go ahead. Please go ahead with your question. Someone was asking a question. You can use the chat box, the chat section to ask a question. You want to type it out. If you also want to speak, you can just unmute yourself, or you can ask for the microphone, and we'll give it to you, please. It's Q&A time. Very insightful session. I mean, you also went into the mathematical aspect of it. Many people don't like math. Yeah, we have a question. Thanks for the great presentation. All right, Odrago Bakri, thank you so much. Thanks so much.
You're very welcome.
Okay, great. That's a contribution. I mean, one of the things that caught my attention, you saying that you published your book in 2020, and
yes,
we're just 3 years, 2-3 years, and you're saying it's already obsolete. I mean, that's so fast for your book to become obsolete, like in terms of what the concepts you're talking about, just within 3 years.
Yeah, there's much of my book is obsolete, but I think the arguments still hold, but they'll change too. Everything's changing very, very quickly. Share slides with you, please. Oh, absolutely. Godwin, I'll send you the deck. Godwin, if you would just please send me a different email address through the LinkedIn messaging where I can send you the slides, and then you can transfer the slides to
yes,
your.
I'll share it. I'll share with the attendees. Very much. We have a hand raised. I can't tell who that is.
Looks like Nasher Rafael.
Okay. That's Nasher Rafael. Can you hear me?
Yes.
Yes, we can.
Okay, so my question is that sorry, I can turn off my video right now in the middle of something. Okay, so I learned there are trends that certain AIs are becoming sentient, and is that a threat to us as humans or to properties? Because if an AI becomes sentient, that means it can make decisions for itself. I read in the news once there was an AI that can check its own codes and write new codes for itself. So what do you have to say about that? And are there regulations that that would curtail or bring or controls any happenings that might endanger lives and properties if that happens?
Thank you, Nasher. Wonderful question. So yes, there has been some journalists who cited, I think you're thinking of someone at Google, an engineer at Google published and said, yes, our AI is now sentient, meaning it has thoughts and human-like feelings. And then they were promptly fired. Well, that wasn't really the whole story. This engineer had also revealed key elements of the program and project he was working on, and the Google company was not pleased about that and fired him. Saying that AI is sentient and has human-like qualities, personally, I think that's not right. That is part of this kind of myth that AI is going to take over and become super intelligence and solve all the problems in the world and then get rid of all people. I just don't see that happening. You know who I listen to? I listen to people like Jeffrey Hinton and Jan LeCun and
Okay.
Andrew Ng, these people who developed the backpropagation algorithms, stochastic gradient descent, who developed the architectures, and they're the ones who say, this human intelligence? Never in a million years. Are you kidding? They are suggesting other architectures. Now, AI can produce outputs, especially in text, that make you think that they have feelings, even if it doesn't. Let's see. Yes, and then you said they are working on what's called guardrails. I'll give you an example. Someone developed an AI tool to take their leftovers from the products that they bought. This was down in San Diego, California. It was just a store that sold groceries and materials, and they would keep track. If you go into your orders and you say what you had left over, it would suggest recipes. One of the recipes it suggested, because people had bleach left over, was like homemade chlorine gas. Chlorine gas slaughtered people by the thousands in World War I. It's a chemical weapon. We need guardrails on these things, but that's very hard to do. And people must be very careful of what AI does. Couple questions here. Alex Storms, why do we use words like intelligence and neural when it's fact it's math?
Yeah.
Look, AI comes from the 1950s from a professor who wanted to raise some money for a conference. Artificial was everything in the day. Let's have artificial milk, artificial sweetener, and artificial this. So they came up with artificial intelligence. People get excited. And this thing can do human tasks that seem really intelligent. I wish people wouldn't call things neural networks, and I wish we did have different terminology, but we're kind of stuck with it. Evan says you touched a little on AI detectives in education and its lack of production grade accuracy. Are there any less technical solutions that are being employed, like verbal tests? Kevin, I'll tell you this. So OpenAI, the company that produced GPT-3 and GPT-4, ChatGPT, they had their own AI detector, and they retired it quietly because it doesn't work. And these things were tested over the summer, and they're average. Some say they're 70% accurate, some are 30, some are 40. They don't work. It's hopeless. It's really hopeless. But yes, any less technical solution. So teaching, we're going to have to rely more on in-class work, writing on paper, or at least on other things where we can control it. And people need to speak. Young people need to communicate. And then let's see. Roy says AI is not close to really be sentient, but AI can be automated to work on its own and look like it's sentient. Yes, that's our problem, especially when it starts screwing up. So we should never, ever trust it. It's just a dumb machine that can be turned off. ChatGPT is a watershed moment. What can we expect in the next 5 years? The next 5 months. Google's Gemini is coming. GPT-5 is going to have trillions of parameters of weights and biases. Look, everyone, thank you so much. There's 6 new messages. I'm sorry, I'm out of time. I have a meeting with a student at 10 o'clock. I have to leave this call. I have 30 seconds. I can't be late. I'm sorry, that's just not who I am. So I'll get the slides to Godwin. Thank you all. Thank you for the discussion. I wish I could keep going.
Thank you, Dr. Brennan. We appreciate so much from Accra, Ghana. We say thank you and have a great day. Thank you, everybody, for joining the session.
Bye. Take care.
Bye.
Godwin, is that Godwin?
Hello.
Hello, Godwin.
Hi. Hi, Prince.
How are you?
I'm doing great.
Okay?
Yes. I've been expectant. I didn't know you're going to come up this live. So I'm making you a co-host.
Okay. Great.
Awesome. Great having you here. Under a short notice, you're able to come attend the event.
I'm sorry, can you say it again? You're breaking up because you're walking around.
Yes, I'm looking for a better
frozen.
spot to hang in.
Okay. You're in Accra, in Ghana?
Yes, I'm in Accra, Ghana, somewhere in West Africa. How about you?
I'm in just like an hour north of Philadelphia and like hour and a half west of New York.
Oh, great. Sounds great. Okay.
Yes. So how much time do we have, Godwin?
We're trying not to go beyond an hour, a
Okay.
maximum of an hour. Yeah. Last week.
How many people are you expecting? How much time should I talk? How much time should I leave for questions? Whatever. How much
We
of an
had
intro are you going to do?
people registering using the Eventbrite link.
Okay.
And okay, we have only one person here yet, so we can do about, let's say, 40 minutes for your presentation. Then we
Okay.
can use the remaining time for Q&A.
Okay, very good. I see there's someone in the waiting room. Do you see that at the top? Charles Guitou?
Okay.
2 people in the waiting room.
I'm admitting all of them now.
Okay.
So there's going to be a 5-minute presentation from Andrew Eng. I'm going to play a quick video. Yes, before we start the session.
No problem.
Okay, great.
You can hear me okay?
Loud and clear.
All right, excellent.
Loud and clear.
And I'll just hang out for a few minutes.
Okay.
So in Accra and Ghana, do you start things right on time, or do you always do some extra time?
In-person sessions, we hardly start on time.
Okay.
Unfortunately, yeah. But this is Zoom session, so
you're the host. You do what you want, Godwin. I'm married to a woman from Germany, and everything is always on time with
really?
my wife. Yeah.
Okay.
And I do have a meeting. I have another Zoom session right at 10. So I will end on time.
On time, right on time. Okay, that's great. That's great.
Okay. But you can start whenever you like. We're easy.
Okay, 4 minutes of time. Let's kick off. Allow for more people to come in. Yeah. So have you started your session yet? Are you lecturing yet, or you're on vacation? School is still on break. I believe you're back in school.
Oh yeah, we're back in school. Everything's running, and it's a very busy semester because everyone's talking about AI all the time, and so I'm very busy. I have many projects going on, and 3 classes, and then there's my son's activities, and so it's a busy time. But I'm happy to be here with you now.
Awesome. We're glad to have you here too. Glad to have you here. I was having a call with the executive director for yesterday because I'm running an event with them as well. She also mentioned what they're doing using ChatGPT for not-for-profit organizations as well, because it seems like they've integrated it into their processes as an NGO. Yeah. So in Ghana as well, I'm planning a major event for next year, maybe Q1 or Q2. But between now and then, I'm having a series of sessions with the law students. Okay. So yeah, so just generally just driving the discussion around AI and whatever is going on and how it affects the legal practice in Ghana, which is a little bit jurisdictional as well. Yeah.
Yeah. So with the advent of large language models like ChatGPT, that is a huge question. What will it mean for text-based businesses like law and lawyers? And my big fear in the United States is that the lawyers who run the country in our Congress, I'm afraid the first thing they'll say is, "Oh no."
Same thing here. Our current president is a lawyer too. Yeah.
All right, you know that too, huh? Right?
Yeah. It's going to be an interesting one. There's only one person I've seen building in that space on the large language model. It's called Kwame AI. So he's building a chatbot, probably. Also another company called Dennis Law in Ghana as well. They've digitized all the law cases. So they are building a chat model, an AI model on top of the cases they already have, so that it will make querying the database, chat-like, since that was mostly driving the AI, the AI frenzy. Yeah.
And anybody can fine-tune these models. The large language models are open source, they're free, and it's very easy to fine-tune them. And so I hope people don't try to build just one legal model. There should be a model for property law. There should be a model for civil law and family law and criminal law. They just whatever, and the more precise they can make it with those documents, the better it will perform.
Wow. I never thought of it that way. That's very interesting. Yeah. So niche space within the law sector,
Niche-based
Yes.
use cases. Okay, okay.
That's really what they should do. It's called model fine tuning. That's what they should do.
Tuning.
Yeah, because we'll go over this in the presentation.
Okay.
These models are stupid. They don't know what they're saying.
They don't know anything.
They don't know anything. But man, they can be really good. They can really make you think that they know things, but they don't.
Yeah, that's a question I always get. So are you referring to Llama, Facebook's open source model?
Llama is a premier open source model, but there are others as well. And yes, Llama is sweeping the scene. But let's see, you can get all these models for free on Hugging Face, and Amazon AWS for their cloud services. They have set up a special tool where you just upload the documents you want and you can train your own version of Llama for very cheap.
Wow, sounds about great.
Yeah.
All right.